Here we go. Number 11. They canceled the 10 and the 5. It came up with 4 over 1. Any questions on that? Questions on that? So everybody had 4 over 1 for their answer? Oh, Ezra.
One. It's not, like, it looks like a 2.
Okay, it's a 1. 4 over 1. Is that your final answer, folks?
No, 4.
Okay, it should be equal to then 4. 4 should be your final answer. Okay? All right, number 12. Number 12. 5/8 multiplied by 6/15. They divided by 5 here. Then they divided by 2 here. Then they divided by 3 here. They ended up with 1/4. Any questions on that? Number 13. They found the least common denominator to be 24. A least common denominator would have been 12. A common denominator is 24. Okay? They used 24 as their common denominator. They ended up with 1 and 2 24ths. Any questions on that? You would divide that by 2 over 2, giving you 1 and 1/12. Questions on that? So they had 2 and 18 24ths minus 1 and 20 24ths. Can we do that?
No.
Can we do that?
You gotta make that 2 of 1 and then add 20.
Yeah, we need to borrow. So even in doing this, that is not correct. So we would need to borrow here, making it 1 and 24 24ths plus the 18 24ths, which gives us 1 and how many 24ths? What's 24 and 18? Work it out. What's 24 and 18? You guys have pencils and paper. 42 24ths minus 1 and 20 24ths. When you subtract 42 minus 20, you get what? 22 24ths. Is that in lowest terms?
No.
We would divide by what? 2 over 2, and that gives us 11 12ths. Did anybody come up with 11 12ths? Okay. Should get 11 12ths. 11 12ths. 14 is up here. They actually worked the problem half of 2/3 instead of 2/3 of a half. Okay? Because they found 2/3 first and then half of it. Okay? By the community property, they still would have gotten a third. Okay? Questions on that? And number 15. Number 15. Do we put the decimal point in here? No. And in the end, is the decimal point here? Huh? No. How many places is it to the right of the decimal point here? 1 and 1 for a total of 2. We would move it over 2. The other thing we could do, if we rounded this, what would it round to? 3 and 2/10. 3. 7 and 8/10. What would it round to? 8. What's 3 times 8? 24. So our answer needs to be somewhere close to 24, which puts a decimal point here as well. Are the digits correct here? Are the digits correct here? Okay. Questions on that? All right. Those topics are going to be on your assessment tomorrow, as well as comparing mixed numbers. Okay? Do you have any questions on those topics? Okay, let's finish off then our other math minutes. Answers. Number one, what'd you get? 8/9. Number two, the greatest common factor of 15 and 33. Greatest common factor of 15 and 33 is 3. Number 3, are the triangles congruent? Maybe you had yes. What's it mean to be congruent? Same size and shape. Number 4, could you cancel it all? No. Who said yes? Where did you cancel, Kaylin? The 4 and 6 are both divisible by 2. What did you get for your final answer? 2/21. Okay. And number 5, how many of you had true? Okay, it is true by definition. Number 6, 27/100 as a percent. 27%. Number 8, how do we put that in lowest terms? Jonathan?
I did 6 over 6.
Divided by 6/6, and you got 3/4. Number 8, what point was found at 3, 2? Dante?
C.
Not C. Not C. Somebody else? Audra? H. You go 3 to the right and up 2. Number 9, what are the coordinates for point A?
4, 2.
4, 2. You go 4 to the right and up 2. What point is found at 3, 4? E. You would go 3 to the right and up 4. This one was out of 15. Please get it recorded. Today is the 22nd, yes. Our assessment topics, do you have any question on any of those topics? Anybody? Okay. All right, e-learning. Again, your stuff was to have already been in. I checked over everything. I spent, I don't know, 2.5 hours yesterday coming through all of that stuff again. Can I say I'm over it? Okay, here's what annoys me the most about it, is when it was due do, I went through it. And that's when I should have gotten everybody's grades, right? I should not have had to go back a second and third time for it, right? That was my third time through on some of it. Very time consuming. You should have done it the first time. All right? Okay. I do want to bring up, later in the class period, what a good slideshow should have looked like for the geometry in the real world. What it should have looked like. Mrs. Call and I came up with this project, I don't know, a long time ago, I should say, but I don't know. I've done similar projects like this over the years. We keep tweaking it a little bit here and there. We did not feel like it was something that should have been hard to do. Yeah, some of the stuff that was turned in, I was like, oh, are you kidding me? We did not feel like the directions were hard to follow, particularly the paragraph that we gave explaining what was to be there. So later on in the class period, I'm going to bring up one that would be a good example that you should, which told me, oh, this is possible, and I got several good ones. And some of you were pretty creative about finding things in your home, and we didn't feel like the shapes we asked for were like unusual shapes that you couldn't have found in your home. Does that make sense? Okay. So when some of the things that were turned in weren't what I thought were going to be an easy 12, hey, let's just walk around the house and find some things, I was disappointed. Particularly when I was working with pre-K, K, and first graders on what their assignments were, knowing what their teachers were expecting. And then I looked at what we were expecting out of fifth graders. And I went, wow, we didn't really up the ante that much. And then I watched what you turned in. And some of you did a fabulous job, and that I'm very pleased with. Some of the rest of you, it's like, you need to step it up, folks. You're in fifth grade. We didn't ask a whole lot. Okay? I realize you're at home. That doesn't mean you back off. You know, look around the room. Can you find a rectangle?
Yeah.
Can you describe a rectangle? We've been talking about rectangles. Look around the room. Can you find a square? Yeah. I didn't say find a hexagon and an octagon. I said find one of the two. Those would have been the two hardest ones to find. Trapezoid, that gets a little hard, but I'm pretty sure in all of your homes you could have found a trapezoid somewhere. Okay? If you look hard, that one you may have had to search. But oh my, search.
Yeah.
Not everywhere there's a rectangle. Rectangle and squares were gimmies. Open your eyes, there's a rectangle, you know? You know what I'm saying? A right triangle. Those aren't hard to find either. Those you may have to do a little bit of searching, but those usually jump out at you too. Describe them. We've talked about descriptions in here. Okay? So when we ask you to do these hunts, you know, look for things, it shouldn't be, oh, I can't find it. It requires you to do a little bit of searching. Searching. Not, I was sitting in my chair and they didn't jump in my lap.
Ooh, that'd be amazing.
You know? Some of you got pretty creative.
All day.
Some of you opened drawers, you opened toolboxes, you looked. You went around your house and you looked. Okay? And that was very much appreciated. I was like going, ooh, look at that one. Oh, wow, look, they've done that. Okay? Which tells me it probably was in other people's homes as well. I know what's in my house. That's why I picked some shapes I did, because I know it was possible. You know what I'm saying? Not like I have a math home that got all these shapes hanging around. No,
Ooh, that would be cool.
no, I don't do that. Oh, let's do a hexagon in my house. You know, no. No, I
That's
don't
when
do
you
that.
are in there.
Okay, find the ordinary house. Okay? All right? So, and the fact that you're on Friday, and I gave some of you extra opportunities to go read the directions again. Okay? All right. Today, we're going to continue on with fractions and whole numbers. Fractions and whole numbers. Let's get our books out. And in our books, we're going to start on page 491. And the story problem today, to start with, is Maya walks a 2-mile fitness trail and she stops to exercise every 1/5 mile. How many times does Maya stop to exercise? Okay. Well, if we take a look at the actual division problem that would go along with this, the division problem that goes along with this is she had a 2-mile hike and she stopped every 1/5 mile. So we want to know how many 1/5 chunks are in that 2 miles. Does that make sense? Okay? So when we take a look at division, we want to know how many 1/5 are in 2, right? Does that make sense? How many 1/5 are in 2? Okay? So one way we can do it is we can take a look at a number line and we can divide it into fifths. And by dividing it into fifths, we need to look at from 0 to 1 and divide that into fifths, and from 1 to 2 and divide that into fifths. Does that make sense? Hello?
Yeah.
Okay. And we can see that there are 1, 2, 3, 4, 5 fifths there, and there are 5 fifths there, for a total of 10 fifths. Do we understand that? Okay? So there are 10 1/5 in 2 whole amounts. Does that make sense? So 2 divided by 1/5 equals 10. How many 1/5 are in 2? There are 10. Now let's get our Chromebooks opened up.
Wow. Wow.
and go to Braining Camp. And we want to go to our fraction pieces. And again, our problem was 2 divided by 1/5, right? So we're going to want 2 whole amounts, and we want to divide them into fifths, right? So the question is, how many fifths would there be? There would be 10. Now, this models it. The number line models it. Okay? But how can we show it mathematically other than modeling it? Okay? If I want to know how many 1/5 there are in 2, well, for every one whole amount, how many fifths do I have? 5. And how many times did I have 5 fifths? 2 times I had 5. Does that make sense? Does that make sense? Okay. So 2 times I had 5 fifths. So here we show 2 times I had 5 fifths. Does that make sense? Okay. Now, notice my numerator is a 1. My numerator is a 1. Okay? Okay? Notice this is a whole number. All right? Let's go back to our book. And let's take a take a look at B. Roger has 2 yards of string. He cuts the string into pieces that are 1/3 yard long. How many pieces of string does Roger have? He started out with 2 yards, and he wants to divide into 1/3 pieces, right? So we want to know how many 1/3s we have, right? If we do a number line, Between the 0 and the 1, how many equal spaces will I need? How many? 3. How many equal spaces will I need between the 1 and the 2? So I have 3 equal spaces here, 3 equal spaces here for a total of 6 equal spaces. I have 6 1/3. Does that make sense? Okay. So 2 times I had 3/3 for a total of 6. Does that make sense? That make sense? Okay. If we go back to training camp. We had 2 whole amounts. This time we broke them down into thirds for a total of 6. That makes sense. Okay. So again, we can show that there were 3 of them there, 3 of them there for a total of 6. Or twice, we had 3 for a total of 6. This 3 represents the fact that there were 3 thirds. This 2 represents that twice we had 3/3. Does that make sense? Okay. Ezra.
So are you basically like finding the 3 and the 4?
Are we what?
Are you basically like 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 so like like so like you multiply 3 and then
I'm not understanding your question, Ezra. Try me again.
do you basically like find like if it's like the like 1/3 and 2? Would you basically find
Multiply.
multiply 3 and 2?
You have to ask yourself how many thirds are in 2. Okay? And then how many thirds make up 1? 3. That's the thought process you need to go through. Twice I had 3/3. Okay? That makes sense? All right. Other questions? Okay, let's go back to our book. Oh, by the way, how many pieces of string? 6 pieces of string. And how many times did Maya stop to exercise? 10. Yep. All right. As we take a look at this one, we have a half strip under a one whole strip to show half a package of clay. We then want a third or a half divided 3 ways. A half divided 3 ways. So we want a half divided by 3. Okay? So if we go back to this, and we have a half. And we want to divide it 3 ways. That means that we're going to separate it into 3 equal pieces. So that needs to be a third, right? Yes, no? Can we do it like that? No, we can't. We need to find 3 pieces that will fit on there. Will a 4th work?
No.
This?
No.
6?
No. Oh.
Okay. So each gram will get 1/6 of the whole package of clay. Does that make sense? Take a look at 3 divided by 1/6. Remember, how many 1/6 are in 3? Well, how many 1/6 are in 1? So 3 times we have 6. For how many total? 18. Okay? Does that make sense? That makes sense? Okay. Now over here, 1/4 divided by 2. When we look at our picture up here, 1/4 is split into 2 equal pieces. We can do that with our braining stamp and show it, which is what they've done here. So 1/4 split 2 ways gives us 1/8. Does that make sense? Right? So, yes.
Can I use the multiply the 4 and 2 and then put the 1 on top?
But you have to understand why it is happening that way. Does that make sense? Okay? So if we're taking a whole number and dividing it by a fraction, our amount is going to get larger because we're looking at how many small pieces we have in there. Does that make sense? If we're taking a fraction and dividing it by a whole number, we're going to get smaller. You got half a pizza there, and I'm going to divide it up among my friends. Is your piece going to be larger or smaller? Smaller, right? Okay. So let's go down here at 8. I want to know how many 1/3 are in 4. Is it going to be a smaller amount or a larger amount? Larger. So is 1/12 going to be true or false? False. I want to know how many halves are in 6. Is it going to be a larger amount or a smaller amount? How many 1/2 are in 6? How many halves are in a whole? 2. I have 6 groups of 2. What's that going to give me? 12. This would have been 4 times 3 equals 12, right? I have 1/8 and I'm dividing it 2 ways. Is it going to get larger or smaller? Larger or smaller? Smaller. It's going to get smaller, right? So is this true or false? I have 1/3 and I'm dividing it 4 ways. Is it going to get larger or smaller? Smaller. Is 1/12 a possibility? I have 1/5 and I'm dividing it 3 ways. Is it going to get larger or smaller? Smaller. Is 15 a possibility? Does that make sense? Okay. Questions? Go to page 497. Erica starts out with 6 submarine sandwiches and cuts each sandwich into thirds. How many 1/3 size sandwich pieces does she have? Well, she starts out with 6, and she's dividing them into thirds. She starts out with 6, and she's dividing them into thirds. Do you see the picture over here? We want to know how many 1/3 size sandwiches she has. Well, how many thirds does she have in each sandwich? How many thirds does she have in each sandwich? In one sandwich, how many thirds does she have? 3 thirds in each sandwich, right? How many sandwiches does she have? 6 sandwiches times 3 thirds, right? Yes? So how many total thirds does she have? So she has 18 1/3 sandwiches, right? that make sense? Does that make sense? So it's 6 times 3, or 18, 1/3 size sandwiches. Here's a picture to prove it. Here's wording with your numbers to prove it. Okay? Questions on it? Anybody? Take a look on 498. Roberto is cutting 3 blueberry pies into halves to give to his neighbors. How many neighbors will get half of a pie? What would that picture look like? Jonathan? Uh-huh. What would I draw? For what? What would the rectangles represent? A piece of pie? Not quite. Adam? Should we draw a rectangle? What do pies normally look like? Yeah. Okay. So, if we want these to look like pies, what should we probably draw? How many circles would we draw? 3 circles for our pies, right? Whoops, sometimes here. A little confused when you guys in your drawing. All right. Like 3 pies. What am I going to do to these 3 pies?
Oh, yeah, got it. How many neighbors will get half?
All right. Okay, easily cut a circle in half. Yeah, yeah. Now, when it starts talking about fists and all that, that's harder to do with circles, isn't it? Okay? And that's when you might want to use rectangles, right? We can easily cut a circle in half. All right? Okay? All right? How many halves is in the first pie? 2 halves. How many halves is in the second pie? How many halves are in the third pie? I started out with 6 pies and I divided them in half, right? Or not 6, sorry.
Yeah.
This is Alan. Started out with
You'll have 6 pieces.
yeah. There are 3 pies and I divided them in half. I know where my 6 was coming from. 3 times I had 2 halves
Wow.
for a total of 6 halves. Right? There's where that old 6 was coming from. How many neighbors will get half of a pie? 6 neighbors will get half of a pie. This over here proves it. Does that make sense? Okay. Could I have done a number line? Would a number line have shown it near as clearly as the 3 pies here?
No.
Yeah. Questions on this business? All right. Do we understand how to use Braving Camp to help us out?
Yeah.
Of course I do.
Okay. Please turn back to page 495. On 495, on 4 through 9, you can draw a number line or use fraction strips, which means that you can use Braining Camp and do like screenshots. Does that make sense? Okay. Questions on that? Okay. Then please turn, yes.
What's the nine? Can we do like the box method? The right thing?
No. And then turn to page 501, please. On 501, I want you to do 2 through 5. Prove your work somehow. Prove your work somehow. Through picture, Brady can't somehow prove your work.
What?
As in writing out what your numbers represent, somehow prove your work. All right? It is due on Wednesday. Due on Wednesday. Question? Yes.
Can we just do the number 495 and stuff? We only do 400, or do we do the rest of it?
Only 4 through 9. Audra and Abby. Try getting something done and you guys talking. Gabby, your Chromebook, please.
In. Stop video. Stop video. Oh, stop, pause, stop recording.